Hey, Cameron here with the Sea Butters Tech channel, and today we're looking at the 9800 X3D. And we're going to be looking at it in a little bit different use case scenario, and that is in a small form factor PC. I have been building out a new computer, and I want to do something a little different with this build. I went from having a very large, very RGB computer to a very small, tiny Fractal Terra ITX build. And I recorded myself building that, and man, there's just so many amazing YouTubers out there who do amazing quality builds and stuff. I don't want to embarrass myself uploading the entire build of it, but I do want to show off the case and my final product, because what we're going to be doing in this video is looking specifically at that 9800 X3D and how well it does in a thermally constrained environment. And you know, this build is so small, it requires a very small cooler with low clearance. So I ended up using the X47 full copper. It's a ThermalRight, it's the ThermalRight AXP90 X47 full copper. Kind of a mouthful, but it's for the size, it's a very good cooler. And we'll be looking at how well the 9800 X3D does in these situations. And I have the what you're here for on the Sea Butters Tech channel. Lots of different test scenarios, graphs, charts of how processors do in these thermally constrained situations. So it's going to be really fun. I've got some really cool data that I'm going to be showing you, and some undervolting results that can show you how much. You know, a lot of people talk about, yeah, give it an undervolt curve, and but we're actually going to see how much that affects things, how much power consumption you can use. So I'm really excited about this one. So I hope you are too. And with that, let's get right into some of these charts and graphs. All right, so I do have a lot of graphs here, and I just want to explain my setup so you can see what you're looking at. First of all, we're going to normally be comparing two different log files of a test that I ran. The test is a 5-minute 16 thread load for 5 minutes to see how, to saturate that cooler, to see how much power can be pushed through that cooler in different scenarios. And how, here's the thing, is this is the package power. We're looking over here. Here's the package power. We'll be looking at the core clocks. And as we push the processor with that cooler on it through these load scenarios for about 5 minutes, eventually, it gets heat saturated, and only so much power goes through that processor, because with this tiny cooler, if you do a 16 thread load, an all core load, it is really going to get very hot very quickly. And in fact, in this thermally constrained environment, it cannot keep up with the temperature. So therefore, what the CPU does is limits the amount of power going through the processor so it doesn't overheat. And this is very similar to what happens in laptops. And I mean, any desktop CPU will do this, but most of the time you have your CPU temps under control in a larger system. This smaller system, it literally does not have the thermal headroom to keep the 9800 X3D fully tamed, and we'll actually see how that affects things. So again, I'll just explain this. We're going to have a line. The red line on this case is our 9800 stock test results, and then the green line is a little bit different configuration, and usually the file name tells you what's going on here. The red line is running at a 100% fan speed, and the green line is that same test running at a 75% fan speed. And then over here, we're looking at the package power. And down here, we're looking at the core effective clocks. So what this is going to tell you is a couple things. There's lots of debate on, how well certain coolers perform and things like this, especially when you're working in a small form factor like the Fractal Terra case. And if you just run stock with just an AXP X47 full copper, I'll show you, you are going to run into some scenarios where you may not be getting full performance. But you can alleviate this, and we'll go over that as well. And that's why these graphs are pretty fun. So to start out the test, I would peg the CPU with this all-core load. And if we're looking at the CPU package power graph, you can see what happened is, boom, we started using a bunch of watts. And the 9800 X3D went straight to 140. And then and I can switch this for a second to core temperatures, you can see it directly went up to 95 degrees very, very quickly. So now it's not going to let it get any hotter. So what it does is it starts saying, oh, let's pull that power down, let's pull that power down, let's pull that power down. And so the only thing we're testing for in the red versus the green in this scenario is how much the fan speed affects the system's ability to cool. I hope that makes sense. So I'm going to change this back to the clocks as well, because ultimately, however many watts you can push through a CPU is how much performance you're going to get. And that takes overclocking completely out of the equation to know what that is, which is why this is really cool. It's a different way that people don't generally test their CPUs this way, but I think it's actually a pretty elegant way to test them, because you're purely testing how much power you can push through the processor, and then you can play with your undervolts, and you can play with your overclocks and see how efficient you can make that power run through it go. But ultimately, how much power you can push through your cooling setup is what's going to limit you. So so the red line is at 100% fan speed, which is a little bit noisy. And the green line is at 75% fan speed. And again, this is with that AXP90 full copper. Another note I should make is I did replace the fan from the stock ThermalRight red fan with a Noctua fan. So that is the only modification that I have there. But still, it's fun to look at, okay, when you run 100% fan speed, how much more performance can you maintain? And this gives us our answer right here. So you can see at the end of the test, the red line was giving us 106.1 watts at the end of it that the processor was able to push. And if you are only running that fan speed at 75%, you'd get 101 watts performance at the end of this. Now, one thing to note is in gaming workloads, you really have a lot of bursting going on. You have a lot of time that CPU has to recover, and you do get the full performance out of that 9800 X3D almost all the time. It's just in these all-core 100% full loads that you might see a difference here. But don't think that this is going to necessarily affect you if you're just playing a normal game that only really utilizes 4 cores at any given time, or even 8 threads at any given time, because the all-core workloads are where things really get hot. So don't think your 9800 X3D is necessarily gimped in gaming performance, because a lot of times it's not, even with a constrained thermal solution. But where you will see the difference is in 100% all-core loads like we're looking at here. So let's add a third file on here, and that is the 50% fan speed. Okay, so now if we look at adding this new blue line in, this is the fan running at 50% speed, and I tried to stop them right at roughly around 4.5 minutes and let them cool down until it hit 5 minutes in this test. But as you can see, I kind of stopped them at slightly different times, which does not negate what we're seeing here. For example, like we have said, if you're running at 100% fan speed, you're going to be able to continue to push 106 plus watts indefinitely, it looks like. And when you get to the green, at 75% fan speed, you're only able to push 101. And when you get to the blue, you'd only be able to push 92 watts. So if you want to keep it very quiet, you're going to lose, you're going to have a delta from 92 watts of performance at 50% fan speed to full speed 106. So that's kind of interesting here. If you look at the core clocks, obviously the core clocks are a factor in how many watts are moving through the CPU. And you can see that you can maintain on the core effective clock at 100% fan speed, you might be getting 4.6 gigahertz, where 75% fan speed, you're getting 4.54 gigahertz. And with the 50% fan speed, you're only getting 4.332 gigahertz. Now, how much that actually affects your performance is probably not a whole lot. The point is the CPU is capable of pulling back power, pulling back clocks if it says, hey, I'm too hot, which is what we're running into here. But I thought this was a really neat look at different scenarios. The next thing that I want to look at is what happens once you start to undervolt the 9800X3D. Can you make up for the fact that the cooler can't quite keep up on this really small build, this really small cooler? So let's take a look at that. Okay, so now we're looking at the red line, which is the 9800X3D stock, and the green line, which is the 9800X3D with a 25 negative 25 curve limiter, negative curve limiter. I think I'm saying that right. And you can see immediately that we're seeing a couple of things here. The package power never reached the peaks of 140 at all under the undervolt scenario. And you may think, oh, that's bad, it's not pushing as much watts, but because it is undervolted, it means it's pushing higher clocks for the same voltage. So if we look at the actual clocks, which are indicative of your performance, you can see that, wow, okay, when we undervolted, we actually got much higher clock speeds all the way across the board. And by the end of this, so you basically had almost right on 5 gigahertz when you were undervolting, where if you weren't undervolting, you were much closer to 4.6. 4.6. So that's actually a 400 megahertz increase in performance at the end of this workload, which is phenomenal. Because using that same amount of power, because these ended up, this is exactly what we would expect to happen. Regardless of the undervolt, you can see at the end of this test, these two graphs, they're using the same amount of power, because power doesn't necessarily equal performance. However, the more power you push, the more you can optimize that power into performance. So by undervolting, we use the same, ending at 106 watts by the end of this 5-minute test, but we're doing it at much higher clock speeds. And these clock speeds are much more in line with what you would have if you did have a beefy water cooling solution or something like that. So basically, we're getting the full performance of the 9800X3D by undervolting, because it now is not getting as hot. And in fact, to prove that to you, I'm going to switch this to the core temperatures. And you can see it didn't immediately spike to 95 degrees and start throttling. It had a little overhead to get up to 95 watts and could continue pushing higher clocks across the end of this test. It still obviously is thermally throttling, but it doesn't do it nearly as quickly. And when it does, it has a higher clock speed. So now we've just compared, 100% fan speed, stock versus undervolted, but how much lower can we push the fan speed and still get the same performance as that stock 100% fan speed? I think that's something worthwhile to look at. So let's look at our undervolted 75% fan speed curve. Okay, and there we go. We can see that we're seeing the exact same thing, even though it's undervolted on that green line. This is with a 25 watt undervolt. The package power can't maintain because the fan speed is lower, so we see less power being pushed to the processor. But look at our clock speeds. We're able to maintain clock speeds because we're undervolted. So even at 102 watts versus 106 watts, we actually keep higher clock speeds. Let's look at 50% fan speed. Okay, and this is where you now see equity between two of these numbers. So obviously, with the fan speed only at 50%, even though we're undervolted, the package power really dips down into those 90s. Okay, so we're at 94 watts at the end of this thing. And that now, with the undervolt, we're getting 4.6 as well. But here's the really cool thing that to consider. You can have at stock and 100% fan speed. You're there. You're incredibly noisy. You're running with 100% fan speed. You can actually get the same amount of performance running at 50% fan speed in a very low noise environment, um, with setting it to an undervolt. So the undervolt lets you run the fan speed at 50% and get the same performance as stock at 100% fan speed in this scenario. Again, this is all very custom to my particular setup, but the theory is applicable to anyone who's building a small form factor case. So yeah, I thought that was super interesting. Okay, so I want to talk about another thing. Now my build here was using a 850 watt Cooler Master, and we're using a 4090 and a 9800 X3D in here. And so what I did is I did a maximum power draw test. So I loaded up all core load, and I loaded up the GPU with Furmark, going very high, and I recorded the power that it was pulling from the wall in this scenario. So I want to make sure that 850 watt PSU could actually handle a maximum load scenario. And you can see that on the screen there now, how much power it was pulling at the time. But then what I did is I ran that 25 offset undervolt on the 9800 X3D, and also I limited the power on the GPU down to 350 watts from the 450 watt limit, because as people discovered years ago at this point on the 4090, you can actually get basically 95% of the performance, even shaving off 100 watts off of the machine. So take a look at those two power graphs and see how much you can save just by limiting your GPU. And it really doesn't affect performance too much. And let's actually take a look at that. Okay, so now here is our CPU package power between these two, and this is kind of the same test as we saw before, but what I've added in here is the GPU power as well. And you can see the GPU power in the stock configuration was all the way up at 450, and then the optimized configuration we're down at 350 watts. But I'm going to change here, and I'm going to actually look at the frame rate that we are getting in the test. And you can see that in this particular test, even though we shaved off 100 watts off of this thing, our frame rates were actually, over 600, minimal. I mean, there's a difference here, but you actually see a more stable frame rate. You see that it's not like clipping. It's not being inconsistent. It's not hitting, power targets that's driving it crazy. And let's look at the GPU temperature as well. By shaving off 100 watts, you move from a situation where the GPU temperature goes out of control in this case, up higher than 80, to really evening out right around less than 75, so about 74 degrees. GPU temperature by limiting it to 350 watts instead of 450 watts. And again, that performance difference is not much different at all here. So I would definitely highly recommend anyone, to, if you have a 4090 or any other video card, because they all tend to do it a little bit. The 4090 just especially responds well to power limiting and overclocking, to basically use 100 watts less for free. I mean, why not? You get less thermal expansion on the materials of your video card and all the items in your case. It's just way more efficient to run that way. Which brings me to my final kind of take on a lot of this. And how much, I mean, it's really fun to build a big water cooled build and things like that with 1,000 blinky lights and RGB. And my motivation, I knew I just was getting sick of the RGB and the flashy lights, especially when it came to this. And that is, I had a height Y360 with 9 fans in it, and they were all RGB fans, and it had the water cooler with the screen on it. It had all the, it had the height Y70 infinity screen. And I was looking at the power consumption on that build, and it would literally idle at about 280 watts, which is a lot of power. And so one of the things I did is I measured the watts. I just told you what the number was on the old system. This new system, this tiny little build with, 3 fans. I mean, there's a couple, I don't know. It's got one system fan, one CPU fan, PSU fan, and 2 GPU fans. But with all the lights turned off, that, I mean, they don't really exist. There's no RGB fans. Anyways, the point is, I went from a system that pulled 280 watts at idle to a system that pulled 150 watts at idle. And that is a big difference, and it's just simpler. And the other thing you get with going no RGB, and I'll probably do RGB again at some point in time. It's fun. There's a place for it for sure. But you have to run all these secondary applications to set the color schemes, and when it blinks and what color it is. And you do get some overhead on the CPU from doing that. And you guys know how bloated some of these programs can be. So that was the thinking behind moving to the build that I did. And I hope this information on how you can optimize your SFF build and what and what undervolting can do for your 9800 X3D in these scenarios and in any scenario, because even if you don't get the temperature savings because you already have your thermals under control in a larger case, you'll still get those power savings and efficiency savings by running an undervolt. Just be sure you test it and make sure that your system is actually stable for the programs that you need to use most. But anyways, thanks for watching. I hope you enjoyed this video. If you did, if you loved it, subscribe, and we'll see you soon.